Hi there everybody, this is Unit 4, Video 1. It is on an introduction to rational expressions. Have your notebooks out and we're going to go ahead and get started. Alright, we're going to start with a definition. What is a rational expression? I'm taking this definition from page 46 of your textbook, and I'm going to actually remind us what a rational number is first. So a rational number is of the form P over Q, where P and Q are integers. Wow, that's supposed to say integers there. Let's try that again. And Q does not equal 0. So it's a quotient, it's a ratio. So my definition of a rational expression is going to be very similar. From the textbook, it says that a rational expression is a quotient. So same idea here, a quotient of two polynomials, P and Q, where Q does not equal 0. Okay, that's a rational expression. So very similar. A rational number is of the form little p over little q. We're using those as integers. And I'm using a capital P and a capital Q here to represent polynomials. Okay, so next up we have to talk about the domain. The domain of a rational expression is the set of real numbers where the expression is defined. Okay, so because we're looking at a fraction here, and my fraction consists of a polynomial, for example, x plus 6 over x plus 2, we need to look to see where my fraction would be undefined. So when I say where is it undefined, you'll tell me what values make the denominator equal to 0. So where is the denominator going to be equal to 0? In this case, I could say that x cannot equal negative 2. My domain would be all real numbers x cannot equal negative 2. To write that as an interval, I would write it as from negative infinity to negative 2 exclusive union with negative 2 to positive infinity. Because I'm using the soft brackets here, it will never actually equal negative 2 in this situation. If we were to write this in a set builder notation, we would write x such that x is an element of the real numbers and x does not equal negative 2. So there's a few ways to write it. Okay? If I were to ask for the excluded values, my answer would be just negative 2. It's the only value that would be excluded from this denominator. Let's take a look at a couple more. Okay, in this case, what we're going to do is we're going to first determine the domain of our expressions. Then we will return and we'll actually go ahead and look at these in terms, lowest terms. Okay, so first off, if I'm looking at this, I'm not concerned in determining my domain about the numerator. All I care about is my denominator, because in the numerator it will always be defined. It's the denominator that will cause us some issues. So I will look in the denominator to find out where this will be equal to 0. To do so, I'm going to have to factor. So I'm going to have to look at what values would cause the denominator to be 0. Taking out a 5p here would leave me with p plus 5p times p plus 4. In that case, that my domain would be all real numbers but x cannot equal 0 or -4. Those are the two places in my denominator that I would have an issue with. If we were to place in a 0 into the denominator, for p, this would be undefined. If we were to place a -4 in for p, this would be undefined. To write that in an interval notation is actually quite messy in the sense that there'd be 3 intervals to do it. Let's go ahead and show you just once here. So I would go from -infinity to -4 exclusive, union with -4 all the way to 0 exclusive, union with 0 to positive infinity. So that's quite a way to write the domain. Alrighty, let's look at the next one for the domain. Here I'm going to factor the denominator to k minus 2 and k plus 2. That would say that my domain is all real numbers, but x cannot equal 2 or -2. And yes, you may write it as plus or minus 2. All right, so then let's talk about what it means to be into lowest terms of a rational expression. The lowest terms of a rational expression mean that all the numerator and the denominator have both been factored completely and all common factors have been reduced. Okay, I'm going to use the word reduced. They're not canceled, they're not disappearing, they've been reduced. If I have a common factor in the numerator and the denominator, essentially I have a factor of 1. Let's go ahead and take a look. We've already factored the denominator in this process, so now I'm just going to have to factor my numerator. So if I were to go ahead and factor this numerator, 2p and a p, then I would have a 4 plus and a minus 1. So that would leave me with 2p minus 1 and p plus 4. Now if you pick up on the way that math teachers write problems, they often, if the intention is to reduce and write them in lowest terms, there'll most likely be a factor that is common in the numerator and the denominator so that the point is actually made and the lesson has been learned. So if you were stuck as to how to factor this, look at the denominator because they probably have something in common. So now I'm going to reduce this. I'm not canceling. I'm actually going to use the word reduce because those over each other, if I have p plus 4 over p plus 4, I have a factor of 1. So this gives me 2p minus 1 over 5p. For those of you that are just dying to cancel and reduce out those p's that are left with the 2p and the 5p, you cannot. This cannot be factored anymore. The factors in my denominator are 5p. The factors in my numerator is one binomial. I cannot reduce a binomial with a monomial. It doesn't work. This is my rational expression in lowest terms. Let's try the next one. I've already factored the denominator here to be k minus 2 times k plus 2. Those are the two factors. In my numerator, I can see that there is a GCF. If I take out the GCF of 3, I will be left with 3 times 2 minus k. But that will not reduce with any of my factors in my denominator. So what if I removed a -3? That way, I would end up with a -2 plus k, which is the same as my k minus 2. You could have written this as k minus 2. That would be fine. Now that will reduce with the k minus 2 in the denominator, so I'm left with -3 over k plus 2. This is a rational expression in the lowest terms. All right, as you're getting ready to start the assignment, I'm just going to make a couple points to remind you. When you're looking for the domain, we're looking for where is the expression? Undefined. To do that, you'd want to factor the denominator, set each factor equal to 0, and those are your excluded values. Okay, and then the other thing we looked at here was writing these in lowest terms. This too involves factoring both the numerator and the denominator. And reducing common factors. All right, just try those problems there that I've got for you to try, and then we can continue working on this in class.